Okay, in this question, we have two diagrams of the micrometer screw gauge. So the first diagram is the picture of the micrometer scale when it is closed. So there is a zero error because we see that there is a reading here. And the reading here, we look at the main scale, there is no reading, and the circular scale, it points to 25. So this zero error is 0.25 mm. And we look at diagram 2 when it is used to measure the thickness of the glass sheet. So we read off from the main scale. It's 1 mm, 2 mm, 2.5. Okay, so 2.5 mm plus the reading on the circular scale, which is 30. So it will be 0.30. So the total reading here, it will be 2.80 mm. And the actual thickness of the glass sheet, we have to minus off the zero error. So 2.80 minus 0.25, we will get 2.55 mm. Answer C. Okay, we just need to label whether the following quantities they are scalar or vector, and we can answer this question. Okay, displacement is a vector, mass is a scalar, speed is also a scalar, velocity is a vector. Distance is a scalar, displacement is a vector, mass is a scalar, and acceleration is a vector. So in this case, the option that fits the header, scalar and vector, it should be B. Okay, we have a speed time graph here. So the gradient or the steepness of the speed time graph represents the acceleration of the object. Okay, so from V to W, we can see that the steepness is increasing. It's getting steeper and steeper. So the acceleration is increasing. From W to X, the steepness is decreasing. It's getting less and less steep. So the acceleration is decreasing. And from X to Y is flat, so there is no steepness at all. So the acceleration is equal to 0. And from Y to Z is a downslope. So downslope means that there is no acceleration, the object is decelerating. And since it's a slope that is a straight line downwards, we can say that the steepness is constant, so the deceleration is also constant. Okay, so in this case, we want to find a region whereby the acceleration is decreasing. That will be WX. Answer B. Okay, now let's look at this fish. There are altogether 3 forces acting on this fish. It will be a 80 Newton upward force here, 20 Newton upward force here, and we have a downward force, which is the weight. Okay, so this fish is being balanced by these 2 spring balances. Okay, so we can say that it is in equilibrium, so the downward force must be equal to the upward force. So the weight should be 80 plus 20 equal to 100 Newton. Answer C. Usually in the case of a moving object, the direction of the friction is directly opposite to that of the direction of travel. But whereas for a rotating object, it is special in the case that the direction of friction is actually the same as the direction of travel. So the answer should be D. Okay, now let's do a simple demonstration to see why is it so. Okay, now imagine my pencil forms the ground. Okay, then I have an eraser here. So this eraser will represent the tire. So it's going to go round and round, and it's going to rub against the ground. So as it travels this way, the tire should rotate this way. So as it rotates and it brushes against the ground, you see what is happening? there is a force that actually pushes the eraser this way to the left, and this is actually the frictional force. So we can say that the frictional force is in the same direction as the direction of travel, which is indicated by D.